Okay, if there's nothing else, I'll bring on our speaker, Conrad Cardano. He's going to talk to us today about solar imaging and astrophotography. So,
Very much. All right. Observing the sun since 2011. Okay, this is a new acquisition I've got. It's called the Skyscraper Pod. I got rid of my old Rubbermaid observatory. What was my age? It's just getting too hard to open and close it. This is great. This was a great thing to get. But solar imaging, I'm hoping that by the time I'm done with this, you'll agree with me. Maybe you'll get interested in some of this. It's not what it used to be. It is really exciting. And I've really gotten into it over the years and I've accomplished quite a bit. I have never seen a presentation on solar observing without, first of all, a warning. Okay, yes, the sun is hot. We all know that. So you never observe the sun without some type of proper filtration. And do take your time to set up. I have a bad habit. Okay, I set up, I got my cameras going, I look at the computer screen, it's black. I forgot to take a lens cap. You know, you get so caught up in things. But that can happen with solar observing too. So take your time to set up just to be safe. You know, my name is Conrad Cardano. I've been a member here for probably 35 years. I've been an amateur astronomer for 55 years. Got a Bachelor of Science, major in physics. A lot of people may not know. I taught physics for 5 years in the Peace Corps, and then I programmed computers for 35 years. In 2011, it all started. I bought a Lunt 35 millimeter hydrogen alpha scope. I had a lot of fun with that. Well, when I retired, I upgraded to the Lunt 60 millimeter hydrogen alpha scope. And a little more than a year ago, I bought a device called a Solex. It's a 3D printed spectroscope. And I bought the optics for it, and this will give me high resolution, multi-wavelength solar imaging. You'll see results from that here. And then a few months ago, I bought a Daystar Quark chromosphere for my 3-inch atom. I did sell that 160 millimeters. Okay, when was the last time you saw the Andromeda Galaxy change, or the Orion Nebula, or the Rosetta Nebula change? They don't change. You know, 10,000 years ago, they probably looked like this. But the sun is changing every day. These are 2 photographs from my spectrohelioscope. And you can see how much it changes. This is a beautiful solar prominence at Lunt. And over a period of several hours, this changes. It changes dramatically, and you'll see videos. And solar activity can be exciting. You know, when you watch this change over a period of hours, you have to remind yourself that you can take the planet Earth and put it right in that hole. That's how big these things are. You've got these bright areas here called plagias, okay, and you never know when there's going to be a solar flare popping out of that. And back in 2014, there was this huge sunspot group. This was so bright, I shouldn't say bright, it was so big that you could easily see it with a pair of eclipse glasses. You didn't need a fancy telescope. Great. Where's all this activity coming from? Okay. Well, let's see. This is, there we go. Deep in the center, with all that nuclear fusion, we're getting tremendous amounts of energy coming out of that. And that energy in the form of gamma rays, X-rays, very slowly makes its way up through this radiative zone. And then it goes into a convective layer. And it's in this convective layer that a lot of things happen. Okay, in this convective zone, there's plasma. Plasma is superheated ionized gas that generates powerful magnetic fields. When you take a particle, you strip the electrons from it, and it's charged. When it moves, it generates a magnetic field. And because there's so much in here, it's a very powerful magnetic field. And a charged particle in a magnetic field experiences a force. And as a consequence, you get all these magnetic field lines all throughout the sun. What's a sunspot? Well, it's a spot that's darker than the surrounding area. The reduced surface temperature is caused by concentrations of magnetic flux that inhibit convection. Those big, powerful magnetic fields have some interesting effects. In some parts of the sun, they retard energy coming up out of the surface, so you'll get that little dark spot. In other areas, it'll be brighter because it's encouraging energy to come up. Oh, and before I forget, if anybody has a question, please raise your hand. I'll be happy to answer. Okay, this is a great year for sunspots. We are now in a solar maximum. I took this, whoops, too fast. Okay, here we go. This picture was taken with a little sea star with solar filters on it, and just tremendous amount of sunspot activity. This one was taken with my 3-inch aperture and a 1-month filter. How to observe them with your scope? It's not hard at all. You can buy ready-made filters. You can buy solar film and you can make your own. That's what I've done in this case. There's good solar film out there. Beta Planetarium makes very good film. You can buy it and make your own. They have instructions with it, however big you need it. It's very easy to do. A Herschel wedge, these are very nice. I've got one here. You're welcome to come up and take a look at it. Okay, it looks like a diagonal, just a 1 1/4 inch diagonal, but there's a very special prism inside. Okay, and that prism will direct all of the sun's heat to the back, while a safe portion of the light will just go right up to where the eyepiece is for your camera. And then you could buy a smart telescope and have that do it for you. As a caution, I would suggest that you deal with well-known companies. Okay, and there's lots of them out there, and a lot of you are going to be familiar with High Point Scientific, Agena Astro, Thousand Oaks Optical, Daystar. Whoops, too fast. As a caveat, I would be careful buying things off of AliExpress. I know things there can be very cheap. Okay, and you can get what you pay for. I bought a little diffraction grating. It cost me $12, and it was poorly made. I had very little use for it. You want to match your filter with the scope. This Herschel wedge is meant for a telescope up to 4 inches in diameter. If you want a Herschel wedge for a 5-inch or a 6-inch scope, you're going to need to get the model that's 2 inches. A bigger scope may actually need to be masked. Okay, if you were to cover, let's say if you had a 12-inch reflector, and you covered the front of it with a big piece of solar film, your image is just going to be too bright. You would be much better off, designing your own front mask, cut a little hole and have your solar film in there. And if you want to do photography, any type of monochrome or color camera will do. But the ultimate in observing is hydrogen alpha observing. This was a picture taken with my lamp back in 2017. This prominence, absolutely beautiful. Okay, just to show you how big it is, here's a picture of the rest of the sun, and you can see how this is. You could probably put the planet Jupiter in the center of that. I wish I had taken a video of that, but I hadn't perfected the technique at that time. What can you see with hydrogen alpha? Well, first, you've got solar prominences, which are large, bright features that extend outward. Next, you have sunspots, which are little cool regions. Then you have filaments. This is a solar prominence, but it's viewed on the surface of the sun and not along the edge. And then you have a plage, concentration of magnetic fields that form bright emissions. Yes, getting started can be expensive. But so are smartphones. How many people have you seen walking around with $1,000 smartphone? I'm amazed. I can't believe that people would spend that much. There were 3 big manufacturers. I don't know what the status of Coronado is going to be in the future. Unfortunately, because it was owned by me, bought by Ryan, which went out of business, I was absolutely surprised that nobody bought Coronado. It's going to go up for auction, probably goods, but once it's gone, it's gone. So there are still a few out there for sale, and you'll probably get them on the used market. One is probably a big one. I've owned several ones, and they're very good. And Daystar makes a few telescopes besides all of their filters. And these 2 are running right now under $1,000. Back in 2016, this is what my solar imaging looked like. I had my 160 millimeter on a Celestron mount. It was pressure tuned. There's a little knob here that you turn. You want to bring out the prominences, you take that up a certain way. If you want to work on the chromosphere, you turn it another way. Very handy. One thing here, something I highly recommend, absolutely great, an electric focuser. Nothing like it, especially for imaging. And then, of course, the camera. And for small features, I'd stick a television Barlow. Cameras, I have 2 cameras that I do most of my imaging on. One, ASI 174 monochrome, and ASI 294 monochrome. In hydrogen alpha imaging, you're dealing with red light. And your color cameras have a matrix of red, 2 green, and a blue filter, okay, over the pixels. Well, the 2 green and the blue filter are just not used. Okay, it's a waste. So you're only using 25% of that monochrome. So if you want to get into imaging, you're going to need to buy a monochrome camera. For frame capture, I like sharp capture. I know some people like to use fire capture, which is also very good. But I've gotten to like sharp cap very much. In fact, I have the pro version, which I think is well worth it. It not only allows me to control the camera, but also to control the telescope. I can control my focus too. It's all very useful. So in order to produce just a single image, okay, with chart count, I may capture anywhere from 500 to 1,000 frame video. And I like the 16-bit SCR file format. The exposure might be anywhere from 1 to 16 milliseconds. And the gain I will leave at 150. And I aim for about 10 to 15 second exposure. But each file gets to be pretty big, anywhere from 0.7 to 1.8 gigabytes. Yeah, that's a lot. When stacking, I'll take that video and I'll stack it, and I like using Auto Stack. Now, another stacking piece of software that's been out there a long time is Registack. A lot of people may be familiar with that. Registack is good. It hasn't been updated in a long time, and I don't consider it user-friendly. It does have one useful feature to it, which is the wavelength feature. But AutoStacker is very easy to use. Okay, I'm just going to open, bring the file in, and you hit the Analyze button. It's going to look at all of those frames and decide which are really sharp and which are not so sharp. And it gives you what's very important, quality graph. Okay, and it sorts them all out on this green curve. You know, the best of the bunch are going to be right up here. There are going to be some due to turbulence that are not very good. And that gives you some important numbers. Then there's a button over here where it sets alignment points for stacking all of the image, and then last but not least, you're going to hit the stack button. And even though I might take a video of 500 to 1,000 frames, I'll only stack somewhere between 20 to 50. I don't need to stack hundreds of them. I've done comparisons, and between 20, 50, 100, 200, the image doesn't really get that much better. It just takes a lot longer to do. And one useful feature with AutoStack is the little sharpen button. You can check off that little box and you'll get a nice image. Like I said, this is a nice image, but it does appear a little flat. We got to do better than that. And that's where image processing comes in. I'm sure a lot of people will agree with me that this is the hardest part of astrophotography because of individual preferences. Some people might like this feature highlighted or some other feature highlighted, but there are two important techniques that are worth mentioning. And the first is what's called stretching filters, aka histogram stretch. It modifies the contrast and the brightness of certain features of the image. And the other is the unsharp mask, which sharpens details in the image. Okay, this graph comes from a piece of software that I've owned for a long time. It's called Astro. Of all places, it comes from Italy. These two Italian PhDs put it together. I like it very much, but there's a lot of good software out there, including free software. So this histogram gives me a graph of here's my dim pixels, here's the very bright ones, and here's the number of very bright pixels and dim pixels. So this is where I start, but I can change the shape of this graph and have it look quite different. And consequently, I've got a whole new image here, very different than what I started off with. After the histogram stretch, My prominences are now more visible. The contrast is much better down here in my filaments. Unsharp masking, this is really neat. It's an image sharpening technique. It enhances all the details in the image. It's fantastic for the planets, the moon, and the sun. Okay, we'll start off with something like this, and when you're done, it's so much sharper. Notice how this filament is much darker. The sunspot is more distinct, and these flow lines, they're much darker. Very easy to see. Now, this is where, and it took me a while to develop this, I call it extreme imaging, time-lapse imaging. I want to see what's going on in the sun, not just at one particular moment, but over several hours. I don't take a single continuous video of the sun. It's not practical. You would have a file greater than a petabyte. To do it, I'm going to take a video of 300 frames, stop, wait 3 or 4 minutes, take another video, and just keep this up for several hours. Okay? The processing does get more complicated. But as you will see, the results are well worth it. Here's a sample. Just a very simple sample of maybe 2 hours worth of imaging. Watch what happens near the arrow. Let's try here. Steps for animation. 300 frame videos every 3 or 4 minutes for several hours. Okay, I'm going to have anywhere from 50 to 100 videos. Okay, tremendous amount of data. The largest amount of data I ever had at one time was like 180 gigabytes. It was huge. What really cuts me off in the process are clouds. It start off beautiful in the morning. By 12 o'clock, you can see these big fluffy clouds coming. I'm going to auto stack each video to produce a single image. Okay, so I've got anywhere from 50 to 100 single images. Then I got to take those 50 to 100 individual images. I've got to enhance them. Okay, histogram, stretch, unsharp masking, and I also have to align them. Okay, I don't want them jumping all over the place. And then at the end, I link them all together to make a movie. Okay, so 50 to 100 frames for my time-lapse video. The position of the sun has to match up exactly. In the case of a full sun, it is easy to do. The software that I have, Astro, if I pick out 2 points on the sun, it will take all of the other frames and make whatever adjustments it needs to and automatically set them right. But in a situation where I've got an enlarged view, I'm just focusing on a single prominence, this is hard because I got to pick a point. Let's say, oh, right about there, that prominence, and then go frame by frame and manually move it around so that they match up. I spend a lot of time doing that on some of these. And then after I get all this done, I'm going to have anywhere 50 to 100 aligned frames, and I'm going to join them together into one big video. And Astro will let you do this. This image right here shows something very interesting that I don't see talked a lot when it comes to imaging and post-processing. You'll have the surface of the sun and this prominence very nicely exposed in the same image. Okay, but it doesn't look like that when I started out. I have to start out and get the sun at the proper exposure so that I can get all of these features out very sharp. And then in my Astro Art software, I draw a mask, I create one, and I separate this solar surface from everything else out. And with the software, I can say, ignore this, and let's do a histogram stretch on this. And I can bring that feature out and save the image. Does create a lot more work. Let's get some videos of the sun, some examples. Let's see. This is a neat one, like this one. You know, this is a great example of you never know what you're going to see that day. You know, there have been times I've gone out and it's been a dud. And then there are other times you get something like this, which is really neat. Now, I did that for several years and I sold the ones because I wanted a spectroscope. At night, I do spectra, I use my spectroscope, and I take the spectra of B-class stars with emission lines. But I can use that device during the day as a spectroheliograph. And, oops, let's go back. Okay, this end gets connected to the telescope. There's a 10 micron plate here. Collimating lens, diffraction grating, camera lens, and then my camera. This camera is for guiding. I don't need that during the day. Again, just what it looks like on the inside. You have the light coming from the scope. I get an image of the sun on the slit. I am actually going to move my scope in right ascension. So that image of the sun is going to move across the slit. Light goes through the collimating lens, hits the diffraction grating, and this is a picture of the whole solar spectrum. Okay, lots of absorption lines. Okay, but I'm going to focus on one of them, and this is an example of what it looks like. It's going to be my hydrogen alpha. Okay, I'm going to use it this way. Okay, so taking the image, I'm going to use the control panel or software, manually move the image of the sun in right ascension across the slit. Slices of the spectrum are captured at a high frame rate, 140 a second. Okay, so you can just picture the sun going across the slit, and this is what my video consists of. Not very impressive looking, but and let's see if I can get this now. All right, this is what the video looks like. The sun going across the slit, and that's with the hydrogen alpha. Doesn't look very impressive, but just wait a few more slides. SharpCat controls the camera and the mount. I'll have a 1600 frame video. I'll take 10 videos in 3 minutes. Okay, I'm going to wait 5 minutes and do it again. And I'm going to keep this up for several hours. And I am going to have over 100 gigabytes of data. There is a piece of software from France called Init. Okay, and it's able to take those videos and do something with it to produce a single image of the sun for that spectral line. And this is what I get. This is a great high resolution image of the sun, okay, from that spectroheliograph. Okay, I'm going to use AutoStack to stack the group of 10 single images to produce a single high resolution image. Remember what I'm doing. I take 10 videos in 3 minutes. I'm gonna run those videos through the init software to produce a single image. Okay, then I take those 10 single images and I stack them together in Auto Stacker to get this one image. And then 5 minutes later, okay, I get another 10 videos. And then 5 minutes after that, another 10 videos. And this just goes on for several hours.
I have a question.
Sure.
So when you go across, when the slip goes across the sun, okay,
Right.
does it take, does it take two slices, one at a time, or does it take the entire sun?
Oh, it's doing the entire sun.
Okay,
This is one continuous video, the sun going across the slit.
okay, so that's one video.
That's one video. Let me go back. And let's try this again. Whoops. Okay, this is one video of the hydrogen alpha line of the sun going across the slit. Okay, it starts off small, gets real big, then gets small again. It starts off small because you got the edge of the sun. It gets real big because now you've got the whole disk of the sun.
So you're not taking an average, you're taking the entire sun,
That's right.
period, after the sun.
Right.
Okay.
Okay, this is a 1.25 hour time lapse video. If you look carefully, you're gonna see some bright spots in there, a little solar flare. Down here, you're gonna see a little prominence jumping out. And to put things in perspective, there's the Earth.
Is the Earth an eggshell also?
Well, one neat feature with the spectroheliograph is that I can dial in different wavelengths. Now, I've added the color to this in the post-processing. But what I've got here, this is the sun in hydrogen alpha light. This is the sun in calcium K light, hydrogen beta light. This is white light. And this is a Doppler that the software will give me. If you can see, a little part here is blue, a little part here is red. Okay, the red part means this is the part of the sun that's turning away from us. And then the blue part, that's the part of the sun that's turning toward us. And on the next slide, I've enlarged that photograph. You can see some reddish here, some bluish there. Okay, parts of the sun moving away, parts of the sun moving toward us. Well, I did miss that one scope. So I decided to buy the Daystar core. I have it up here. You're welcome to come and take a look at it. It looks like a great big Nagler eyepiece. Okay, really it does. And it's got a hydrogen alpha filter built into it. And you could put an eyepiece or a camera in it. There's two models, one to emphasize the chromosphere, that's the one I have. And there's another model that just emphasizes the prominences. It actually has a 4.2x bar built into it. So the one I have here only works with scopes that have a short focal ratio. The one I'm using it on is an f6. If you have, let's say, an f12 refractor, there's a different model for that one. It works well with telescopes up to 100 millimeters. You don't need any other filters in front of it. But beyond that, because so much energy is coming in, you're going to need an energy rejection filter. Just some sample images that I took with it. Again, beautiful proms. I got the prom and the sun. Let's get this little video. This is a big one. This is actually not too long ago. Let's try it again. It was too fast.
That's
Yeah, I really like doing this. And, there is some nice websites that give you great information about the sun. These are from the government. One is called GONG. Global Oscillating Network something. But, I can go there, I can see from different scopes around the world, is there activity? And then I'll try and go out and get it. This was probably a month ago, a big 300,000-mile filament. This is a video. And you don't see the sun moving very much. Let's try it again. There may be a little, yeah, you might see a little bright spot over there. Little mini solar flare.
So that's more than the distance between here to the home.
What's that?
That filament, the length,
Yes.
is longer than the distance between here and the home.
Yes, that's true. I was out of state at the time when this was on the solar edge. And I missed a good one, because I would love to have photographed that. So just going back and review, solar observing has come a long way. For a long time, it just meant counting sunspots. But it's not that way anymore. You can observe and document changing features like filaments, prominences, flares, sunspots. Okay, and yeah, I agree, getting started is expensive. But what I like about it so much is that you have an opportunity to do astronomy during the day and not just at night, because you never know when you're going to get a clear night. Thank you for your time. Do you have any questions? Conrad. Yo.
The virtual wedge,
Yes.
no filter needed in front of it.
Now, with this, okay, and I've used this many a time at Frosty Drew Public. I have a 3-inch refractor, put this in the back, with the eyepiece here.
And also it's a white light paint, right?
It's a white light emulsion. I know with some solar filters that you put on front, some are white light, you might get some that are orange, which is kind of interesting, but yeah, but if you have a bigger scope, you're gonna have to get the more expensive model. Questions? Okay, we got
The last device that you mentioned.
Yes.
Yes, what's the price on that?
that's 13.
1,300.
Yes, it's expensive.
I
You
would
know,
work really good
hydrogen
on
alpha
my,
is expensive.
I've got an 80mm F6.
Okay, that would work fine in this, not a problem. Jeff Padell, Jeff, you're supposed to be out there somewhere. I know you're out there on Zoom. He's used it on a bigger scope, but the manufacturer recommends only up to 100mm. And if I wanted to use this, let's say on a 5-inch or a 6-inch refractor, okay, then you need energy rejection filter in the front just to reduce that heat a bit. Okay, to make it safe to use here.
Right, they're using all the telescopes. I mean, special filters that, I mean, especially for those telescopes where it can use other.
Like on a sea star.
Yeah, like that is.
I could not use that on the Sea Star. What the Sea Star has with it, it's got a little solar filter that connects right on front. It's made of material very similar to this. It produces an orange view of the sun, which is kind of interesting. And when you have it set up right, you just tell it to go to the sun and it goes.
And that's a white light image.
It's a white light, but it's orange tinted. Oh,
How well does aligning all those full frame photos of the sun work when there's a lot of activity going on? You talked about the difference between some of the really tight frames versus those full frames aligned.
Yeah.
Do you find that it's as reliable as it is if I'm shooting something deep sky, or is all that change kind of muddy it?
That's interesting, when you're shooting deep sky, there's plenty of software out there that helps you with the guiding. That's not true with solar imaging. That's why there's a lot more work to it. If I could get that type of solar guiding, it would make my life a lot easier. There are some beta versions of PhD. I don't know how many people are familiar with PhD, and trying to use it with solar guiding. And I tried it, it wasn't successful. So, some of these things are just in progress. SharpCat has one where it's supposed to follow the solar features. It didn't work very well for me. So I'll still wait and still look. Astro Art. I haven't used it, this new feature that came out where it will take the sun and it inverts it. Okay, so your sunspots now look like stars. Okay, and the rest of the sun is black. And you have it guide on the little black sun, on the little white sunspot. Having it think that it's a star. I need to spend more time on it.
That's smart.
I have another question about ShopTown. The latest version has auto focusing in, you use that with planetary sun.
It does have autofocusing in there. I haven't used it. I find with solar imaging that if I focus on a feature of the sun, about every 15 minutes, I gotta double check it. Because of all the turbulence and everything else, the focus will change. So and the autofocusing feature with SharpCat was really designed for stellar. Okay, it works well with that, but with solar, there really isn't a lot out there.
So complicating the tracking, okay, so you've got the sun that's appearing to move across the sky, right, which is the rotation. But then you also have features like sunspots and filaments that are also moving across the surface of the sun. Is that what adds to complication?
No, that doesn't, because when I put the video together, you not only get these little things shooting out here and there, you also get the rotation of the sun added to it. For example, in that last one with the 300,000 mile filament, it may not have been obvious, but the sun was rotating in that too. I'll spend, if I were observing today, I might spend 2 or 3 hours taking videos, and then tomorrow I would spend the whole day processing that. And maybe another day after that, if I like what I see. Hold on.